Hello, my name is Alex Cunningham, and I am here to talk to you about black holes, but more specifically, black holes into the context of how they would be created in a liquid star model versus a gaseous star model. So let's first start off with the article that I read. So the article is "Impossible Black Hole Discovery" by the James Webb Telescope. It was written by Paul Sutter, who was an astrophysicist. It was published November 2nd, 2024. November 22nd, 2024, pretty recent, kind of. And I would say in science, I would say that that's pretty recent. And then it was published by Life Science. So the article basically focuses on talking about the gigantic supermassive black holes at the center of our universe and how those could possibly get there, because when we look back in time to when we think the universe was created, we still see these super giant massive black holes being created. And what's weird about that is we only know of one way that black holes can be created, and that is in the context of a star being born, a massive star being born, and then going its entire lifespan and then burning out and creating this small black hole, and then that slowly expanding over time. And we just, in the timeline that we have set in the universe right now, we don't have that much time. Like, it is literally impossible for us to be having that much time. So the theory that this article goes into is that uh I'm looking at my notes, I'm sorry. Is that these black holes were created during the Big Bang, that they somehow, in some way that the Big Bang happened, were created and then expanded upon during the Big Bang. So the current theory is that they literally could have just been born this way, born directly from matter and energy compressed to high densities and the chaotic fluctuations of the Big Bang. However, these black holes would have to have found themselves in the densest part of the universe to collect as much matter to get to these astronomical sizes. And there's not really any evidence that points to it, and it is purely a hypothesis. But that being said, any hypothesis that we could think of for astronomy makes sense, because obviously after the Big Bang, if the Big Bang to have happened, then it would be this expulsion of all of this matter, all of this huge crazy energy that could have possibly replicated that of a supernova. And so it wouldn't be out of the question to say that these supermassive black holes were to be created during the during during the Big Bang. That's what the article was about. It was talking about this new hypothesis, and the discovery, that the impossible discovery was the discovery of these supermassive black holes still being there at the time that the universe was first created. That was the huge discovery, if I hadn't already said that. So let's talk about the liquid star model. Now, this is very interesting to me, because while I was researching this, especially and specifically with the into the context of black holes, since the liquid star model is so new, it is such a new idea and we haven't really tested it, there's not a lot of information that goes towards figuring out what that could mean for black holes in general. So I guess I should say, what is a black hole? How are they created? And it's a region in space-time where gravity is so intense that nothing, not even light or time, can escape. And it's formed from the collapsed stars, the collapsed cores of stars, of massive stars, after they have exhausted their nuclear fuel and undergo supermassive explosions. Um, Obviously, star death in a gaseous star model is that the star has all of this energy, and then it stops forming all of this energy, and then it slowly collapses in on itself, and then the core, reacts to itself, and then it has this super massive explosion, which creates black holes, obviously. Duh. I just think that the concept of black holes is really interesting, because it's so weird to think that something can swallow up everything, I guess. Like, that's just so interesting to me, because it's like, how can this star, in a metaphorical sense, that brings us life, brings us energy, create something that's so deadly? Like, that's so interesting to me. But moving on from that. So that's what it would look like in a gaseous star model. And with a liquid star model, it's kind of the same thing. When we look at it, it's, sorry, my notes are on all different pages. The idea of, so it says that the idea of a liquid core could help explain some of the chaotic behavior observed in a dying star. And that's when we see the signals of detected in the peaks and valleys of a star spectra, which is like the wavelengths of the electromagnetic radiation it emits, and shows that the star is either churning carbon or energy deep within its nuclear fission. And this was found in a star near the Triangulum galaxy. This was observed with a star in the Triangulum galaxy that's getting ready to supernova, and getting ready to emit this vast amounts of energy, and it's having this reaction that we've never really seen before. And so so scientists, not me, I'm a broke college student, are trying to explain like all of these things. Oh my god, how am I at 7 minutes? Okay. So, when we're talking about liquid star models, we talk about supernovas and black hole formation. In a liquid star model, the dynamics of a supernova could be changed because of its fluid-like state. Again, I say could because there's not really a lot of studies on this, and a lot of it is a question of like, oh, this could happen because of this. It would have a more controlled collapse. This could lead to a black hole that has a more moderate spin and potential lower angular momentum, and the accretion disk formation could be more fluid and transform, causing it to be like non-irregular. So it would be a regular excretion disk formation, which is interesting to me because black holes usually have irregular excretion disks, which makes me think maybe it's not that all stars are gaseous or all stars are like liquid core. Maybe some are gaseous and some are liquid. I don't know. I'm skeptical on the whole liquid model thing, mostly because there's not a lot of information about it. But if there's studies going out, because obviously when we talk about a lot in class that black body radiation cannot come off of a model that is strictly gas, and it can only come off of one that is purely liquid or solid. That's like huge evidence for me. But I also am skeptical because it's really hard to recreate the vacuum and elements of space inside of like a testing lab. So that's another whole other thing. And talking about this really got me thinking about the zero radius star. If its core is more fluid-like, the behavior of the core could slow down or redistribute mass in a way that might affect the final collapse stage. But I am running out of time, and thank you so much for such a wonderful term and letting me do this whole project. I think it's so interesting. Thank you, and I hope you have a great term.